so now on your Polar Packet worksheet, you'll see why we went over conic sections, because we're now going to change our whole equations from rectangular to polar form, and in doing this you might run into conic sections, or you actually will sometimes. All right, in rectangular form, we know this is a line. And so now I want to get it in polar form, and I'll actually go over and graph it for you, or at least talk about it by hand. The key to go from either form, this or this, back and forth, is this little picture. It's very, very key. This is theta, x, y, and r. This is actually a right angle right there if I'd drawn it a little better. So let's draw it again, because it's going to be very important to our work. All right, so this is your angle. This is x, y, and r. And we know a lot from this picture, and it really answers all of these questions. All right, so every time I see a y, so I know that sine of theta is y over r. And so we established earlier that y is r sine theta. So sine of theta is y over r. I'm going to multiply r on this side. And you get used to that when you're working in polar or parametric. Cosine is x over r, and so I get x equals r sine theta. And other things I get from this are tangent theta is y over x. And I also have the Pythagorean theorem, x squared plus y squared equals r squared. We use these two to go from rectangular to polar. We take out y, and we can put in r sine theta. 5x, we take out x, and we put in r cosine theta. All right, then we can cancel the r's out of both sides, and we have sine theta equals 5 cosine theta. And then when I divide by cosine theta, we can say tangent theta equals 5. There's a little bit easier way to actually get this that I normally do. I normally would actually do this on an easy one like this. I would just divide y over x equals 5 and go straight to tangent. Y over x is tangent. All right, so, and you'll get the line y equals 5x, but however, you can't even put this into your y board, which is actually your r board, because there is no r here. As you saw in my previous example, it canceled out. But you could actually work it by hand if you started to take angles. Every angle that you go on, you're going to move out 5 units. You're going to go to this angle. I don't know why it's doing that funny little thing. So if you take like an angle like 45 degrees, the tangent of 45 degrees equals 5, wouldn't equal 5, so you've got to find all the angles that give you 5, and it would start to go out and back like this. And so it's like a constant. So you would find all of the angles, you'd turn that way, and you'd walk all along this, and it would give you that line. And we can talk more about that in class also. Right now, all I really want to do is change it from rectangular to polar form. Now on this one, this is really interesting. X, I'm going to put in r cosine theta for an x and square it. Y, I'm going to put in r sine theta, subtract the 1 and square it, and now I'm going to do some algebra. This one's r squared cosine squared theta. This one I actually am going to do FOIL to, r squared sine squared theta minus 2r sine theta plus 1 equals 1. And so I did FOIL there. Now, if I factor out an r squared here, which I really don't have more room to write, and so I'll write it over here, I guess, since I had this one was finished so fast. So follow my work over here. All right, so over here I'm going to have r squared factored out of cosine squared plus sine squared. Minus 2r sine theta. And when I carry my 1 down here, it cancels out, so that's equal to 0. So sorry for the confusion. I'm going to carry it up here. We know from our identities that's just 1. So I have r squared minus 2r sine theta, so I'm going to move it to the other side, equals 2r sine theta. And I can cancel out the r from both sides, and so I get r is equal to 2 sine theta. Now I could go to my calculator and graph this in polar coordinates for you, but remember what we've learned before. Let's talk about that on a new slide. Let's see if I can find one on this. A new big white spot. Let's see. Sorry, I'm using a different app, so I'm looking for another page. All right, so what we just did was we had x squared plus y minus 1 squared equals 1. If we think about what we just learned, the center, this is a circle because the x and y are both squared and they have a 1 coefficient. The x hasn't been moved over at all, and the y would go up 1. So as a center at 0, 1, and a radius of 1. And so we would get this picture. Now we just changed it with polar coordinates to r equals 2 sine theta. So think about what we learned about polar coordinates. If I graph r equals 2 sine theta, this gives me the diameter of a circle that's up on the y-axis that looks like this. Same exact equation. You could find a few points, like for instance, if you found the sine of 90, you'd have 2 times 1. So when you turn 90 degrees, you would go 2 units, and so on and so forth. So anyway, that's a good example of one is written in rectangular coordinates, and if I type that in my calculator, in polar coordinates, I would get the same picture. So it's the same equation in rectangular coordinates and in polar coordinates. So what's happening here is, sorry, I'm going back to our problems that you're doing for homework. If I didn't already pass them, I think they're right in here. I won't do that again. Hopefully I'll find another place to write. What's happening here is you're going out x and up y to get the picture. So you're going out x and up y to get whatever picture it is that you're making. What's happening here with r equals 2 sine theta is you're turning at an angle and going straight there to get the same picture. All right, this one, based on our experience just a second ago, this is an x squared that makes a parabola. All right, and for y, I'm going to put r sine theta. It's for y. For x, so I have x squared over 5. And for x, I'm going to put r cosine theta. Then I'm going to work it out. So it gives me r sine theta equals r squared cosine theta over 5. So I'm going to multiply the 5 to this side. Now I can get rid of the r's, and I get 5 sine theta equals r cosine theta. And then I might as well solve for r, and I get r equals, if I put sine over cosine, I get tangent. So r is 5 tangent theta. It'll actually make this parabola. I think I have it in my calculator here, in my whiteboard. I don't. So let's put in r is, oh wait, I'm sorry, I messed up with my square. Sorry. Glad I caught it before I typed it in. I forgot to square this. Some of y'all may have noticed that. That's r squared cosine squared. So this is still squared. And so when I divide this, this is what actually happens. When I solve for r, I have 5 sine theta over cosine squared theta equals r, which gives me this. 5 sine theta over one of these cosine thetas, and that leaves another one on the bottom here. So in your answer sheet, you'll see 5 tangent theta secant theta, which I do have in my calculator from working it before. I don't, but I have something similar. So I'm going to put in 5 right here. I'll go up here, and I'm going to change this to a 5. And we ought to get that parabola because this is tangent theta, secant theta. And we'll get a parabola, but one thing that we get is a really weird looking parabola, because now we've talked about polar coordinates, and I don't remember what mode I'm in, if I'm in radians or degrees. I think I'm in radians, probably. And so if I go back to my calculator and change my window, hang on just a minute, close this, change my window, and this actually is going to have something to do with something we learn later called parametric. We have thetas, and it gives us x's and y's. So it's really got what's called a parameter in it. You don't want to step by 0.5 in radians, and so I'm going to change it to a step of 0.1 to get more points, to connect the dots and get a smoother curve. Remember, this is like skewed. So we get this parabola that we learned about earlier in either today or in algebra class. This is just a parabola with a center at 0, 0, and it's got like a stretch. So we get that graph. All right, now I know I don't have much room for this fourth one, but that's okay because it goes pretty fast if I treat it like number 17. I'm going to divide y over x equals 3, and y over x is tangent. So now I'm in polar coordinates. Tangent theta equals 3. What's kind of frustrating is much like a line like x equals 7. I cannot actually type this into my calculator, but I could find all of the angles that give me, the tangent of what angles give me 3. To make this make a little more sense, let's talk about what would happen if you were trying to graph tangent theta equals 1. Okay, so let's make an r theta. We can't even make an r theta chart for that. Let's just list all our thetas that would happen. If you used pi over 4, you'd get 1. If you used, let's see, negative 5 pi over 4, you'd get 1. Like this, if you turn pi over 4, you'd get 1. If you turn negative 5 pi over 4, you'd also get 1. And that would be like if you had the line y equals 1x, you would start to get this right here. If you started naming all of the angles, they give you a tangent of 1. So you walk out this far, and you walk out this far, and these are the only two places tangent is positive. So if you're trying to make a tangent 3, it might tilt your angle some, and you get a steeper slope to make that happen. All right, now, so changing from polar to rectangular, you're depending heavily on x is r cosine theta and y is r sine theta. This also plays later on into something called parametric. All right, now we're going to go with the other parts of this triangle where the tangent of theta is y over x and the Pythagorean theorem, x squared plus y squared equals r squared. We'll use those to go from polar to rectangular to get out of the thetas and into x's and y's and get out of thetas and r's. This is x squared plus y squared equals r squared right here. All right, so I'm going to have r is equal to tangent theta is y over x. Secant theta, if we look at secant of theta, cosine would be x over r, so I'm going to flip that over and get r over x. That gives me r is equal to yr over x squared. So I have x squared r equals yr. Cancel your r's and you get y equals x squared. So if I actually type that into my calculator, I just get a parabola that we talked about earlier today, or if, depending on when you've watched the video. All right, here, if you just have a plain theta, it's a good idea to put tangent in front of both of these. If you're working a lot of these problems, you would get used to it. And this will reiterate what I said earlier. Here, if I put tangent here and tangent here, I get tangent theta, and the tangent of 5 pi over 6 is square root of 3 over 3, and then y over x, tangent theta is y over x equals root 3 over 3. Sorry, tangent of 5 pi over 6 is negative root 3 over 3. So then my final answer is y is equal to negative root 3 over 3x. You just keep playing with this very familiar picture from your trigonometry. And so if I type, well, you can't even put this into your calculator, theta equals 5 pi over 6, because this doesn't act like a function with polar mode, but you could graph theta equals 5 pi over 6 and you would get this line. If you have theta equals 5 pi over 6, you turn 5 pi over 6 and you walk forwards and backwards always and forever, and so you get this right here. All right, now here I'm going to be putting in cosine is x over r, sine is y over r. Or you could also, I wouldn't here, but sometimes it works to square both sides. Okay, so now, and sometimes we even introduce an r. In fact, that would work here. Let me go and do it this way, and then I'll do it the other way. All right, here if I multiply everything by r, on this side I get r squared, and on this side I get negative 6x plus 2y. I know r squared is x squared plus y squared equals negative 6x plus 2y. Oh my goodness, it's starting to look like a circle. So I'm going to go up here with it. We'll work up into here since I don't have much space on this worksheet. So now I'm going to get it equal to 0. X squared plus 6x plus y squared minus 2y equals 0. I'm going to complete the square. Half of 6 is 3 squared is 9. Half of 2 is 1 squared is 1. So I'm going to add 9 and 1 to both sides. Add 9, add 1. Factor x squared plus 6x plus 9. Factor y squared minus 2y minus 1 plus 1 equals 10. Well, goodness, when I work this, I ought to see, when I graph it, a circle with a center, with what we just learned on conic sections, of negative 3, positive 1, and a radius of 10, or a little more than 3. All right, so let's look at the picture, especially now that I've adjusted my step. And I already have it, I think, put in my whiteboard right here. So this is number 23, negative 6 cosine theta plus 2 sine theta at the top. That's in polar coordinates, and you find all those points and graph it. But we also see that it does give us, this is skewed, it does give us a circle with a center at negative 3, 1, and a radius of 3. So pretty cool. All right, so this would be your answer right here, and you can see it on your page. Okay, now for 24. Oh, back here, you had another alternative that I'll write down here. On 23, you could have also introduced an r, multiplied everything by r. Like multiplied this side by r and this side by r. Sometimes people do that. R squared is x squared plus y squared. R cosine theta is x. We knew this. R cosine theta was x. And R sine theta is y. So I have plus 2y. And then I could go on with this step right here. So on this one, it might help to introduce an r into both sides, but not probably with tangent and secant. It might work. Let's try it. If I introduce an r, I get r squared on this side and 4r on this side. Tangent theta is y over x. Secant theta, if you're looking at secant of theta, you're going to have r over x. And so I have r squared equals 4r squared y over x squared. So that gives me x squared r squared equals 4y when I multiply over here. 4y r squared. So I multiplied this over here, and I had this. The r squareds cancel, and so I get y is equal to x squared divided by 4. And so if I took time to type this into my calculator, I would get a parabola with a compression of 1/4. Sorry, it's kind of messy, but again, you can see the answers on your answer sheet.